Hi, this is Mike Human. I'm here at Flash Memory Summit 2019, and with me is Thad Omura from ScaleFlux, one of the founders or pioneers in computational storage. Nice to have you here, Thad.
Pleasure to be here. Flash Memory Summit 2019.
So tell me a little bit. I'm sure you guys have a lot of announcements, right? Trade shows are always a place
Yeah.
where you see lots of announcements. What are you announcing this year at FMS?
Lots of really fun stuff going on this year. So this year we're focused on launching our CSD 2000 series of computational storage drives. And what these drives are offered, what I have in my hand here is in the U.2 form factor, but it's also available in PCIe standard card form
Nice.
factors. What we're doing with computational storage drive is we are moving compute functions closer to the data. And in an effort to really speed up application processing, application performance, shorten runtimes, reduce latency, and give the user a much better user experience.
Kind of map reduced, but on the lower scale in a sense.
There are some features like that we
Yeah.
implement. Specifically, we are accelerating things like analytical queries right down
Very
on the
nice.
drive. But what's really interesting and novel about the CSG 2000 is not only do we have those application level accelerations, we've also accelerated compression transparently on the drive.
Very nice. That's always, for a lot of companies, that's a big issue. Compression has always been one of those trade-offs where, yes, you get more capacity, but you're trading off speed in a lot of cases, right?
Absolutely. So there is always that trade off because a lot of different applications use compression when the CPU is
Right.
performing that particular workload. And what ends up happening is the application slows down. So with our transparent data path compression, what happens is you can really use the technology penalty free.
Nice.
Product goes right into the application. Data is immediately compressed and decompressed in the data path. A lot of benefits.
Very cool. Very cool. So I know looking at your website, you've got a lot of different applications you support, especially on the analytics side. Are there specific use cases you're seeing that computational storage really has a home for or has really naturally been strong in?
We have, and ScaleFlux has been very much focused on database and big data applications.
Makes sense.
And when we look at the database side, where we're seeing a lot of interest is this idea to be able to converge and to unify fast data and big data in the same platform.
Yeah. Well, and you hit upon something that a lot of people have talked about the show. We're getting so much data out there, right? A petabyte of data 10 years ago was a lot of data.
Yep.
Now it's not so much, right?
Not so much.
But it's a lot of data to try to ingest into a server, do all the computation on it, and then make some use of it in something close to real time becomes incredibly difficult. If not, it cost prohibitive, right?
It is. And when you talk about like workloads moving, they've quickly moved from petabytes, terabytes to petabytes. What has to happen for any type of data manipulation in traditional systems
Yes.
is all that data has to go up to the processor.
That's right.
Right? You got to move all the data. And it's not only about the data movement,
Yeah.
it's the fact that all that data has to go somewhere. So it's likely polluting your DRAM.
Yes.
So the DRAM capacities are
And
going
there aren't
up as
petabyte scale DRAM.
There's not petabyte scale
yet.
DRAM. So really what computational storage is about is simplifying the I/O path by doing that heavy lifting functions right at the drive. So usually what's happening here is you're just setting up the answers of some complex queries or some, complex workloads.
Right.
Letting the CPU do the manipulation at that point and doing the heavy lifting of all of these queries and searches and what have you. Do that at the drive level, then the CPU can do the other stuff.
Very good. Very good. That's certainly, I would imagine for a lot of applications, especially on the edge, where now you have a space penalty and power penalty as well. That's very powerful, right? You can't deploy a cluster of 2 or 3 or 4 racks of servers into a space on an airplane, for instance.
You're absolutely right, and that's why these technologies are all about being able to scale applications, still deliver the performance, still deliver the ability to work on very large workloads, but in a much smaller infrastructure footprint.
Yeah.
Exactly to your point, because as 5G emerges,
Yeah.
you're going to see more computing closer to the 5G towers and towards the edge.
Yep.
And what a lot of people are starting to understand about 5G, of course, there's more bandwidth, but there's much lower latency,
Yes. Yes.
right?
Exactly.
And in order to take advantage of that latency, you're going to need to push the compute on the other side of that 5G connection closer to the edge.
That's right.
Otherwise, you're sending it all back, and the latency value is lost.
That's right. That's right. Same with the Internet of Things, right? I'm sure there's huge applications in that space as well for computational storage.
There are, because what's happening now is the amount of machine-generated data is just skyrocketing over user-generated
That's right.
data.
That's right.
And all of those machine-generated data, all of those things collecting, whether it's video or other data, sensors, those are all on the edge.
Yeah, absolutely.
And what is valuable is to be able to analyze that data as quickly as possible with
Yeah.
the lowest possible latency, again pushing computational storage to the edge.
Exactly. Seems like a natural set of conditions that bodes
Yes.
well for you guys.
That's absolutely right. So we're seeing it not only in kind of leading infrastructure for these database and big data workloads, but we are seeing more and more interest in pushing to the edge. And in that case, it's all about infrastructure footprint reduction, also
Yeah.
power reductions as well.
So what's the next big thing you think is going to come up for computational storage in the next year or two?
There's a couple things that we see. The first is an expansion of the number of applications that can just run computational storage turnkey.
That would be good.
Yes. And what ScaleFlux is doing about that is we are introducing computational functions like compression that are just transparently accelerating applications. You
Nice.
just go into the system, the application runs faster. That's the first thing. The next thing is we really need to start to converge as an industry on how do we activate all of these compute functions. So standardization efforts within the
Yes.
Storage Networking Industry Association Technical Working Group, that is a big effort to make sure that vendor drive A, vendor drive B plugs in. The compute activation
Yeah.
is the same way. And then the third thing we see is, not only the applications, but standardization. But the third thing is we're going to see how more and more compute functions in the drive, not just it's doing one function, but it's going to be doing 2 or 3 that are significant.
Okay.
So you're going to see application level acceleration accelerated by maybe the underlying storage acceleration and
Right.
transparent compression.
Right.
So when you start to add these things up, now you're going to start to see even a multiplier
So it's
effect
not a
to the value.
2x, or
That's-
4x, it's a
th-
10x
there
or
you go.
20x. Yeah.
Absolutely.
That's excellent. Very good. Well, thank you very much. It's great to have you here. Great to
Absolute
hear
pleasure.
from what you guys are doing, and
Thank you
looking
so
forward
much,
to seeing you
Mike.
next
Yeah.
year at Flash
You
Minutes.
got it. Take care.
Thank you.